Hello everyone. Today, once again, Sudarshan Sharma is here with you with 10th class physics. Last time I have elaborated to you about the convex mirror, plane mirror, the cases, and some numericals. This time I'll be helping you out with the concave mirror and its cases in detail, then numericals. Fine. So let's go ahead without wasting any time. So, concave mirror, rather reflection in concave mirror. So this is your concave mirror and Mn is the aperture of the concave mirror. The line which is passing from the pole, focus and center of curvature is called principal axis. This is called principal focus and this is center of curvature. The distance of this from pole is called as radius of curvature. This is called focal length. Okay. So in this we will discuss 6 cases. Fine. So let's go ahead with the first case. How the cases, what is the nature? Let's discuss that in detail. If the ray of light is coming from infinity, this concave mirror is also called converging mirror. Converging mirror. Fine, because it converges the ray of light at the focus. So suppose I make from this side also, so you will see that the ray of light is converges at the focus. If you place a piece of a paper here, it may burn also in bright sunshine. Fine. So what is the nature of the image? What is this the name of the case? Let's write it case number 1. When object is placed at infinity, infinity means very large distance. When the object is placed at infinity means at very large distance where the image is formed. Image is formed at the focus. Highly diminished, very small, point sized at the focus. So what will be the nature? Simply you have to write nature. The image formed FORMED is real and inverted. Real and inverted. Highly diminished. At the focus. At the focus. So this is the first case. This is the ray diagram. Very simple, very easy to do. If the case will come directly, you have to make the diagram and just try the nature. You will get 1 marks. So let's go for the second case by just modifying it. Case number 2. When the object is placed between infinity and center of curvature. Suppose here, when the object is placed between C and infinity, where the image is formed, C. Always make one ray parallel to principal axis. This is your principal axis, and second ray always pass from the center of curvature. So center of curvature is always at approximately double distance from the focus. So the ray of light which passes from the center of curvature traverses back in the same direction because it is normal to the mirror. It is normal to the concave mirror. So where these two lines are meeting, rays are meeting, there your image will be formed A dash, B dash. So this is your U, distance of the object from the pole. This is your V, distance of the image. This is your focus, and this will be your center of curvature from here to principal to the pole. So what will be the nature in this case? Case number 2, when the object is placed between infinity infinity and C. C means center of curvature. C means center of curvature. So the image formed will be real and inverted again, not highly diminished. Diminished means smaller in size. Smaller in size. Smaller in size, we can write diminished at where between the focus and the center of curvature, between C and F. Between C and F. Now let's go for the third case. So simply you have to make this type diagram, and this diagram 1 marks, and you write nature, so you will get half marks here, 1.5, 1 marks. Generally this type of question comes, okay? Or with the help of this diagram, if you can remember it, you can solve easily the numerical associated with concave mirror in which the object is placed behind the center of curvature. Fine. So I'm going for the case number 3. Case number 3. Let's write case number 3. So the case number 3 is when the object is going little near here at the center of curvature. So how the image will be formed and where the image will be formed, let's make it where the object is, case number 3, when object is placed at C, at CENTRE, center of curvature, that is at C. Okay, so from here, this is your focus, this is your center of curvature, object is placed here. So a ray of light always will pass from the focus. Second ray of light you can pass from the focus, and you will see that they will meet at C only. And if this is your AB, this will be your A dash, B dash. Again, real and inverted image of the same size as that of the size of object. So this is the nature, and you have to write nature. Nature, nature, the image formed, FOR, is real and inverted of the same size, as that of object at C only. So just below the center of curvature, same size. So in this case you can see U and V both will be same. U will be same, V will be same, both will be negative. As per sign convention, U is always negative. All the things which are kept to the left hand side of P are negative, and so this is negative, this is negative. Your height of object is positive here. By arrowhead you will show like this, and H dash is height of image, that will be also negative. So if these things are coming in the numerical negative, this is negative, then obviously your numerical will be also correct. So simply you have to remember the case number 3 like this. So let's go ahead with the case number 4. Let's go a little nearer from C, between C and F, where the image will be formed. Let's see. Fine. So the case number 4. Case number 4. When the object is placed, case number 4. Case number 4. When the object is placed between C and F. C stands for center of curvature, F for focus, where the image is formed. Let's see. So you have to remember it. Very easy to remember. Very easy to remember. This is your pole. This is your suppose focus. Approximately you have to make. And here you are making object. This is your AB object. You have to represent it with the arrowhead. First I said you will make parallel to principal axis one ray of light, and it will come back to your focus. It will come back to your focus. Straight line with the help of scale will make. Second ray of light which you will make, that will go from the double distance near root center of curvature will take. So if I increase the size of aperture, that will be better to make it, and a ray of light will pass from center of curvature. I am shifting it here where they are meeting. where they will be meeting, that is the height of the image will be formed at that point. So this is your image A dash B dash. So this will be V little bigger than that of your U. So this is your U negative, V negative once again. So this is your R, center of curvature. This is your focal length from focus. This is the way how you will be making, because I said you previously also, when the ray of light passes from the center of curvature, it is coming back in the same direction because it is normal to the mirror. It is normal to the mirror. Fine. So what will be the nature? Let's write nature. The image formed is, again, the image formed is real and inverted. Real and inverted, high magnified, larger in size. Also you can write larger in size or magnified. F-I-E-D, magnified. So it is larger in size, magnified, behind B-E-H, behind C. So beyond C you can write. So this is the way you will be making the diagram, and this is the nature, real and inverted image. When case number 5, let's go for case number 5, delete it and let's go ahead with case number 5. Let's go a little close from here to focus where the image is formed. Let's find out. So the next case is when the object is placed at F. When the object is placed at F means at focus, at F-O-C-U-S, where the image is formed. So this is your MN, this is aperture, and this is your principal axis. It's passing from the focus and center of curvature. So at focus, if your object is placed where the image is formed, the ray of light will pass straight back from the focus only. Second ray of light you will pass from the center of curvature. So both rays should be straight with the help of I'm making with the without scale, so you will be making with the help of scale. So it will go parallel. So these lines will not meet, they will be parallel, and the nature you will be writing, the image formed is real and inverted, highly magnified, H-I-G-H-L-Y, highly magnified at infinity. Simple, very simple. This is the way you will be doing. If case will come, directly you will make the diagram and write its nature. If the numerical will come, then you are supposed to solve. What is position of U? U is equal to F here, and V is equal to infinity. So V is equal to infinity. Very simple. F is always negative in concave mirror. Okay. In convex mirror it is positive, in concave mirror it is negative. U is always negative. So V depends upon the situation. Right now it is negative. Fine. So I am coming to the case number 6, last case. Case number 6, very simple. When the object is placed between F and P, P-O-L-E, that is your P. Focus and pole, F-O-C-U-S, focus, that is your F and P. Let's make it very simple. This is your M, this is your N. We call it aperture. This is your P. Now object is placed, this part is P. This is your focus. Object is placed here. When object is placed here, where the image is formed. The image will be formed. Just see, a ray of light always passes from focus, I said. So you will produce dotted after this. This is the only case, we call it virtual and direct case. So from here, this is reflected back in the same direction, and from here you will, where they are going to meet, that point will be called as, so you can make it dotted. So this is the position A dash to B dash AB. This is your U. F is a little greater than U. This is your V. V will be positive, U will be negative, F will be also negative. So what will be the nature? Nature will be the image formed is virtual and erect, magnified, but magnified or larger than the size of object. Virtual and erect image. Virtual and erect image is that image which cannot be obtained on the screen, which is on the positive side. So V will be positive, U will be negative always, F is also negative. So these are all cases of concave mirror. You have to remember these cases. If you remember these cases, with the help of these cases, you can easily solve your all numericals. Let's go ahead with 1-2 numericals so that you come to know how to solve the numericals. Numericals are very important in this. Generally numericals are asked, or these cases are asked in the examination, CBSE examination. So I am coming ahead with a numerical. For solving any numerical, you should know mirror formula. Last time also, in my last video also I told you. So mirror formula is very easy. 1 upon F is equal to 1 upon V plus 1 upon U, where V is your distance of image, U is distance of object, F is focal length. And one more formula which you require, that is your magnification formula, that M is equal to H dash upon H, which is equal to minus V upon U. This is your magnification formula. Sometimes if radius of curvature is given, you know radius of curvature is 2 times focal length. This also you have to remember. With the help of this you can find out. Let's do one numerical. I'll make one numerical from my side, so you can practice some numerical from NCERT or some additional book. So here come numerical. When object is placed at 20 centimeter in front of concave mirror of focal length 25 centimeters, say, find the distance of image form, and also find the height of object if height of image is 10 centimeter. Height of image is 10 centimeter. Let's solve this numerical. Given what is given to us, first of all we have to understand from the question what is given to us. When the object is placed 20 centimeter, object is placed means U. This is given, U is equal to 20 centimeter. Here they have given positive, but according to sign convention we are supposed to write it negative. So second thing, F is given. What is that? Focal length is 25 centimeter. Focal length is 25 centimeter. This is concave mirror. Focal length of concave mirror is always negative. Concave mirror written here. Okay. So H dash is given to us. This is 10 centimeter. So what we have to find? We have to find V is what and H is what. These two things we have to find out. So question is here. Let's go ahead with the solution. So you have to directly use the mirror formula, and using mirror formula you have to solve it. So let me solve it by using mirror formula. Using mirror formula, 1 upon f is equal to 1 upon v plus 1 upon u. So f 1 upon minus 25, u, v we have to find out. So this will be minus here, 1 upon 20. So let's calculate it, 1 upon v. 1 upon v as it is. So this can be shifted this side. So 1 upon 20 will be positive, and this 1 upon 25. So LCM you will find it will come 100. 25 is a 5, 4 is a 25, 4 is a. So 1 upon v, v is equal to reciprocal to 100 upon 1. So v is 100 centimeter, that is your positive. So similarly, so that means it is virtual and direct image if it is coming positive. So last thing which we have to solve, that is magnification. Using magnification formula, m is equal to h dash upon h, which is equal to minus v upon u. So you can use here h dash was 10 centimeter, h we have to find out, minus v, v is 100, and u is equal to your 20 centimeters. So with negative sign, this will cancel out, 0, 5, so which implies h is equal to goes up 10 upon 5, so h is equal to 2 centimeters. So 2 centimeter is the height. So what is the nature? So nature at the end you are going to supposed to write the nature. Nature is mandatory to write. So what is the nature? The nature is the image. The image formed is VIRTUAL, virtual and erect, highly magnified or magnified, you can decide, LARGE, larger in size than the object. You can write magnify. Fine. So let me make the diagram for this. So diagram for this will be case number 6 directly, because V is positive. So this is your concave mirror, this is your principal axis, and this is pole, this is your focus, center of curvature. Object is placed here. Because 25 centimeter, 20 centimeter will be approximately this. U is equal to 20 centimeter with minus sign. F is equal to minus 25 centimeters. So this is your F. So a ray of light will go like this, and you have to trace back it from focus. Second ray of light you can make like this at the pole, and then produce them. Where they are going to meet, that will be meeting point will be your image A dash, B dash. This is your AB object. So that's your V, which has been calculated 100 centimeters. So this is the ray diagram. So this complete question comes for 3 marks, and with the nature you will be writing, and with diagram, everything. Similar type of 10-15 question you can practice. From net you can get the question, from some additional books, some NCERT books. All questions are similar, same formula. Practice makes man perfect. Thank you very much. That's all for today.